So we've talked about how to find absolute maxes and mins of continuous functions on closed intervals. And now we want to gather more information about what the derivative tells us about functions. And then for next class, try and figure out where we have local maxes and mins as opposed to absolute maxes and mins. So let's start out by thinking what it means for a function to be increasing and what it means for a function to be decreasing. And let's just draw a graph here. And let me draw some function. So if you looked at this function and asked yourself, where's this function increasing? What would you say? And so if I were me, I would think about a little person walking along this graph. If they're walking along the graph from left to right, kind of like we always read from the left to right, we read graphs from the left to right as well. So if they're walking along the graph, are they going uphill or downhill? If they're going uphill, then the function's increasing. So it looks like they would be going uphill up until probably this point. So the function would be increasing on that interval. Okay, then they get to the top of the hill, and if they keep walking, now they're going downhill. Okay, so the function is going to be decreasing if we're going downhill. So we're going downhill. If we were sledding, this would be a really steep downhill until we get to here. So the function is going to be decreasing on that interval. And then we start walking uphill again, and it looks like we're walking uphill for the rest of this graph. So the function's increasing again. Okay, so that's fine and dandy if we think about uphills and downhills, but how does that relate to calculus? So do you notice anything about the slopes where the function's increasing on those blue intervals? You might notice that the slopes are positive where the function's increasing. And so let's say we have positive slope where the function, and we're thinking about slopes of tangent lines here. And then where the function's decreasing, the slopes are negative. Okay, well, positive slopes of tangent lines, well, that just means that f prime is positive. And negative slopes means that f prime is 0. So a function is going to be increasing when the derivative is positive and decreasing when the slope is negative, or when f prime is negative. And so this is the increasing decreasing test. So when the derivative is positive, the function's increasing. When the derivative is negative, the function's decreasing. Pretty straightforward. The question is, how do we implement this? So let's go ahead and see how we do this. So as you might guess, the first thing we want to do is find the derivative of our function. So this function's derivative is 6x squared minus 6x minus 12. Okay, now we have to know where the derivative is positive and where it's negative. The best way to do this is to start out by finding where it's equal to 0. So find where the slope is 0. This is like the same thing as finding the critical numbers. So we can pull the 6 out here. We have x squared minus x minus 2. And we should be able to factor this. So it looks like x minus 2, x plus 1 is 0. So the derivative is 0 at 2 and negative 1. Okay. What we're going to do now is we're going to draw a sign chart. I like doing these. These are fun. And hopefully you guys will have some fun with these sign charts as well. I'm going to label my sign chart with f prime because all the information that's going to go on here is coming from the derivative. In a couple of class periods, we'll label our number lines with f double prime. So you really do need to indicate what derivative we're looking at here. For now, we're just looking at the first derivative. The first thing I'm going to put on my number line are those places where the derivative was 0. In this case, negative 1 and 2, making sure we're putting them in numerical order. Okay. And wow, didn't mean to zoom in there. So now what I'm going to do is I'm going to pick a number in each of these regions. So this region, and this region. And I'm going to plug them into my derivative to see whether my derivative is positive or negative in those regions. So let's pick our favorite number less than negative 1, maybe negative 2. Okay. And I want to know, is the derivative positive or negative? Okay. The best place to look is looking at the factored form of the derivative. If I plug negative 2 into that, I'm going to have 6 times negative 4, which I'm just going to indicate as negative number. I don't care what number I get out. I just care if I get a positive or negative thing. And then negative 2 plus 1 is also a negative number. And let's actually maybe even just indicate that 6 is a positive number instead of a 6. So I have a positive times a negative times a negative. That gives me a positive out here. So the derivative is positive if I plug any x value in less than -1. Okay. If I pick a number between -1 and 2, maybe like 0, it's always my favorite number to plug in. 6 is still going to be positive. Once again, I'm plugging things into here. 0 minus 2 is negative. 0 plus 1 is positive. Positive times positive is negative. And then finally, let's plug in something bigger than 2, like 3. And once again, I'm plugging it into the derivative. So I'm going to have positive. 3 minus 2 is positive, and 3 plus 1 is positive. So that whole thing is positive. Okay, so the derivative is positive, less than -1 and greater than 2. So the function will be increasing. So f is increasing on the interval from -infinity to -1, because that's this interval. And we're not including -1 because at -1, the derivative is 0, which means the function is neither increasing nor decreasing there. And then from 2 to infinity, once again, we're not going to include 2 because the derivative is 0 there. Okay, so f is increasing on these intervals, and let's explain why. And that's because f prime is positive. Okay, be careful here with your phrasing. Don't say it is increasing because it is positive, because your it's mean different things there. So say f is increasing because the derivative is positive. Okay. F is decreasing where the derivative is negative. So that is going to be between -1 and 2. So f is decreasing on -1 to 2. Once again, we can't include the -1 or 2 because the derivative is 0 there. So the function is neither increasing nor decreasing. This will be since f prime is negative. Okay. So if we look at the graph of this function here in just a second, we'll see if this matches. Okay, so we're looking at the graph now of this function. If I zoom out a little bit, so it looks like the function's increasing till it gets up to its peak here, which is at x equals -1, and that agrees with what we saw. Then the function's decreasing from -1 down here, which is 2. That's what we saw as well. And then the function becomes increasing again. Okay, we noticed something about the fact that we have like a local max here and a local min here, and the function changes from increasing to decreasing. That's something interesting to keep in the back of your mind for next class. Okay, so I will stop recording this example here. You should go ahead and try the next couple examples, see how far you can get. I'll record solutions in the next video.